So thanks for coming into the session. I want to give you a quick overview of what we're going to talk about in this session. So for the people in the room who are new to Cloud Firestore, I'm going to give you an introduction on what it gives you, why we built the particular product, and then I'm going to jump into what's new. So we've got a couple of exciting announcements of new features and functionality we're launching for Firestore, so we'll cover that. Then we'll go through some common architectures that we've seen during our beta program from actual customers who are using the product, some of them who are in the room today. And then Kathy will come back on, talk about how Google itself is using Cloud Firestore for an application you might all be familiar with, and then give a quick demo and look at some of the code behind that demo. And then I'll come back on, we'll talk a little bit about scaling tips, and then we'll probably do a Q&A if we have enough time at the end. So to start, let me talk a little bit about what this session is really about. It's really about helping you understand how to build scalable apps using GCP and Firebase, and in particular, using the Cloud Firestore database. Just to kick things off, can I find out in this room who has used Firebase real-time database before? And who has used Cloud Datastore before? And who has already played with Cloud Firestore? I might need to get some of you to come do the presentation. There's actually a lot of people in here. That's awesome. So I want to start by painting a picture or an architecture of something that I would have used to have done. Let's say you're in a company and you're building a new mobile web application. How would you go about building that in a traditional way? You would start off with a web server for your static content. Then you might have a dedicated application server for the dynamic content that's changing and mutating as your users are using it. You probably have a database server running somewhere, running on some sort of persistent storage. Then you're probably thinking about adding in replication so you can do maintenance without having to bring everything down, maybe give yourself some high availability capabilities. It's not too hard to add. And then as your app starts to get more successful, you're probably thinking about disaster recovery and how would you build that? So now you're worrying about a standby data center. You've got VPNs and carrier interconnect that you're building. At this point, you've got some pretty heavy infrastructure that you've built, and you've got full-time people maintaining that infrastructure. Well, what we want to do is give you tooling that abstracts that away and gives you something where you can focus on just the app that you're writing. So with Cloud Firestore and some of our products that we have in the Firebase platform, we can simplify that final architecture that I showed you with a very simple setup. You can use Cloud Firestore directly from your devices, and you can use Firebase hosting for storing and serving the static content, and you can use Firebase Auth to give you that secure interface into it. And then finally, you can use Cloud Functions to expand into the many other tools that we have within GCP. So when we built Cloud Firestore, we really believe in giving tooling so that small teams can accomplish big things. And by providing those small teams with powerful yet simple tools that get out of the way, we can give them a foundation for success. And lastly, we want to make sure this tooling is available everywhere. So let's start off with some of the basics behind Firestore. So we have Firebase SDKs that we've integrated with that give you native client libraries on iOS, web, and Android. We integrate with Firebase authentication to handle the authentication into the server. We have a declarative security rules language to allow you to control access to your data based on not just the properties of the signed-in user, but also the information in its database itself. We give you Cloud Functions to integrate into the rest of the platform, and we also use Firebase hosting as a convenient way to serve up content. Now, it is expected in apps today that they would just work across mobile and web. You may not have intended this to happen, but it's a basic expectation most people have today, that they can pick up their phone and continue using what they were using on the web, and sometimes even use both of them at the same time. There's a further expectation, which perhaps some people in the audience have discovered today, that network connectivity is not always available. There are environments, even in our hyper-connected world, where you need to have offline capabilities in your app. And we've built a lot of tooling around this to make it simple to enable these use cases in your application. Further to that, we know people are building some very complex applications on our tooling, so we have a full suite of server client libraries, including C#, Go, Java, Python, PHP. These particular toolings allow you to use our serverless database in a way that is truly scalable, regardless of what architecture you want to use. We have got a multi-region replicated database to make sure it's always reliable and available for you, and I'll talk a little bit about that in a second. So just to finish off the actual database itself in this quick intro, I want to talk about how the data is structured. So we spent a lot of time with the real-time database people to understand how people are using their data and what ways they want to naturally use it. And for Cloud Firestore, we're using a collection and document model that allows you to store related data together in a semi-structured fashion. So let's quickly talk about what is new. And these are all coming shortly, starting in August and then rolling out through 2019. So the first one that I want to talk about, Cloud Firestore, is going to have a lot of new locations launched. So currently we have a multi-region location in the US. And starting next month, we're going to gradually roll out the full suite of locations that you see here. Whether it's in the Americas, Europe, or Asia Pacific, you're going to be able to locate your database and your data closest to where your particular user base is. We are also announcing, and this is of interest to the Cloud Datastore customers in the room, that Cloud Firestore is now going to support Datastore mode. Cloud Firestore is designed as the third generation of Cloud Datastore, and it's going to support all the existing APIs and client libraries that you use today. We are going to seamlessly upgrade everyone, so you don't need to change your code and you don't need to worry about downtime to get the properties that we have in this new system. Some of those properties I will go into in a second, but they include things like being strongly consistent for all queries and having a 5 nines availability SA once we get to GA. The beta for this new mode starts in August. So you're probably asking, what's the catch? So let me talk about a couple of the things that we're removing in Datastore mode for Cloud Datastore users. The first thing that we're removing is the entity group restrictions you have today. So no longer will you be limited to 1 write per second per entity group to get strongly consistent data. So hopefully this is a good thing we've removed for you. The second one is you no longer need to use ancestor queries to have strong consistency. All queries across Cloud Datastore, when you're using Cloud Firestore in the new Datastore mode, will be strongly consistent. And the last thing we're removing is the 25 entity group limit for transactions. It doesn't matter how many entity groups you use in Cloud Datastore, we will support the transactions for it. Just want to quickly touch on the upgrade, because I know a lot of you who have got Cloud Datastore databases are wondering how this is going to happen. So we are doing the upgrade for you. The Google engineering team is going to be live migrating the information from Cloud Datastore to Datastore mode without any downtime. We will send announcements out about this to our user base in the coming weeks. There is no action required on your behalf. We are going to handle everything. There are no code changes that you need to do, and all the existing functionality, APIs, and client libraries you use will still work. If you want to play with it early, you can create new databases during our beta period, and once we get to GA, we will start upgrading. So I just wanted to quickly point out some of the differences in case you're wondering when you would use Datastore mode, the new mode we're announcing today, and native mode, which is the existing mode Cloud Firestore users have been using in beta. There's a couple of minor terminology differences between them. Datastore mode is designed as that server-side database, and the native mode is designed as your backend as a service for your mobile, web, and IoT applications. When you think about Datastore, think about a NoSQL database that scales from 0 to 1 million writes a second. When you think about native mode, think about a backend as a service that scales from 0 to 1 million concurrent connections from your devices. We've also just published our draft SLA. So this is the SLA that will go into effect once we get to GA. For our multi-region locations, it's 5 nines of availability, and for our regional locations, it's 4 nines of availability. This system is designed to make sure your app is up and running when you need it. In August, we are also releasing managed exports for native mode. So this will allow you to take a full export of your data into GCS and import it back into your project if you need to recover some of that data, or perhaps import it into another project, a dev or a QA environment. You can also take these exports and import them into BigQuery, so you can use a full SQL language to do ad hoc reporting against that data. We have also added the data viewer for native mode into GCP's console. So starting in August, you will see a new Firestore tab where you can see our live updating UI to manipulate and query against your data. We are also adding a new set of functionality around managing your indexes. So for those who haven't used Cloud Firestore before, we automatically index all your fields in your document. Sometimes you want more control over that, and so we've got a new system that allows you to selectively turn on and off particular types of indexes for your documents. For those people who have got sharp eyes, you may have seen a new indexing mode down the bottom called array contains. So Cloud Firestore will now be able to do containment queries against arrays. And I just saw a little fist bump, so that's a good sign. So now I want to talk about some of the common architectures I've seen with customers who have been using Cloud Firestore successfully. The first one I want to talk about is Guesswork. Guesswork is a machine learning startup for helping e-commerce companies in emerging markets. They recommend new products for first-time buyers on their site. When a new user arrives on the site, Guesswork collects a whole bunch of data points about that user, where they're coming from. Did they come from an email campaign or a fashion website? And including other things like the geographic region and the device type. They then come up with a recommendation based on this user, and the data can take a couple of passes to get back to the user. So let's have a quick look at one of the examples they did with a company called Zalora in Southeast Asia to bring better e-commerce recommendations to their customers. So to start with, they were using the Google Tag Manager. You may be familiar with this if you're using Firebase Analytics. With the Cloud Firestore SDK to write information back into Cloud Firestore about the user who visited the site. This then triggers a couple of different data pipelines to process this data. The first one is triggering a cloud function that then inserts the data into BigQuery. This makes the whole data set available to the recommendation engine to do processing. The second pipeline that gets kicked off with a cloud function is using the Cloud Vision API to process image. Now this, I think, is really interesting because Guesswork deals with so many different languages out there. They've found it more reliable to use the Vision API across the image of the product to get metadata back than relying upon the text metadata and trying to understand and process all the different variations of language. So you get better, more consistent results by processing the image of the product. Their recommendation then uses this information to take two paths. The first one is for anonymous users. They write the recommendation back into Firestore, which gives a real-time update out to the client for that user. For registered users, they can send a periodic email with the recommendations to them. So here is the whole architecture on a single slide. It's very simple, but very powerful. And this architecture has allowed them to move very quickly and make changes. So they can A/B test different algorithms to improve their recommendations and improve, obviously, their revenue. So one of the things that I really love about this example is Guesswork is a company of 3 people that they bootstrapped using this technology, and they now serve 100 million users. So 3 people managed to bootstrap a successful company to serve 100 million users using this tech. That's all about the small teams able to do big things. Now, this is another example I love. Hawken Dynamics. They're probably one of the most interesting meetings I've been on. You'll see some force plates on here. We had a video conference with them, and they were in the back of the room jumping up and down, doing counter movement jumps on plates. It's probably one of the most energetic meetings I've had. So Hawken Dynamics is a sports performance company focused on providing cutting-edge technology in both software and hardware for athletic teams. They optimize athletic performance by analyzing the information from these force plates using things like counter movement jumps and isometric tests. And so let's have a quick look at their architecture, which is very simple, and there's one little bit I'll add in a minute, but it really is this simple for them. So they've got force plates that they give out to teams that at a very fine grain level measure the force of the movements of the athletes. This information is then wirelessly transmitted to the mobile apps, whether it's a phone or a tablet that Hawken Dynamics has. These apps work offline because not all the locations where they're doing this test has network connectivity. On the app, they can quickly review the raw data that the force places produce and maybe get the athletes to repeat the test or look for something new. When they are connected, they use Firebase Auth to authenticate in and sync this information into Cloud Firestore, which once again kicks off Cloud Functions to do further processing on the raw data, to pull out moving averages and other information that then they can display in more depth in their mobile web application. So when they are online, all of these are kept closely in sync with each other, so you can see in real time what the results are. They sent me a copy of their data model so we could have a quick look and see how they structure it, and this uses some of the collection and document hierarchy that we provide within Cloud Firestore. So they have an overall collection called teams where all of the sports teams they have live within, and they have a document that just has some basic information about that team. Under the team document, each team has a set of data, the settings for how they want to configure the displays and the tests that they have, the actual raw data that gets synced from the force plates, the tests, which is a computed result that comes from Cloud Functions, and the different groups that different athletes within those players on that team exist. So let's talk about the athletes, which has a document that outlines a bunch of information about when they were tested using arrays, what different groups they're in, what their weight is, etc. And then under that is that computed average doc. So a player can go in and look at their performance over time and how they're improving based on different training schedules. So with that, I want to hand it back to Kathy to talk about how Google has been using Cloud Firestore.
Thanks, Dan. So if you're looking at this screenshot, this page is probably one that you actually know and have already interacted with. It's the Google Cloud Next conference website. Our developer friends at the Nerdery actually built the web and mobile apps for this event using Cloud Firestore. They, like many developers often do, work with existing systems and storage solutions rather than building from the ground up. Even so, Cloud Firestore can still work well in this case. We'll first take a look at some of their actual data in Firestore to give an example of how some application data can be laid out, and then we'll zoom to the whole system. This is a view of the Firestore data viewer in the Firebase web console, and you can see there are top-level collections for, in this case, events, with documents for the Cloud Next events in San Francisco, Tokyo, and London, and the latter two are coming up in the fall. It's a flexible data model, so your application can write whatever you need. In this case, there's some metadata fields on the individual days of this event. We also have some English language sub-collections of all the content that you'll see on the conference site, such as the homepage and marketing copy, the event sponsors, and the filters that you use to narrow down your view of the day's programming. Lastly, here are the sessions in a sub-collection with documents for every one of the general sessions that you might attend, including the one we're sitting in right now. There's the document with a list of labels for the topics, a room capacity, and as you might imagine, if the size of the attendee list for a session reaches the room capacity, then the application logic will set the can reserve Boolean field to false. So now that you've seen a view of some of the data, how do the developers use Cloud Firestore to improve on the app from prior years? Nerdery already works with an existing third-party SaaS provider that specializes in event management. So they store all the conference data, such as sessions, speakers, registrants, rooms, and map data. They can read directly from here, but since there's no event-driven model for responding to changes in your data, the app pulls this information on the order of many minutes, which in the past has led to registrants quickly filling up sessions on the day of and a slight delay in showing that status. Now, Nerdery copies all of their event data into Cloud Firestore, which they use as a single source of truth for all apps to read from. They also wrote a custom API served on Google App Engine, which accepts writes from clients, such as a user bookmarking a talk, and handles transactions to the third-party system. Then the clients read directly from Firestore to display all the data that you actually see. Here's a view of the whole system, and we can contextualize it with an interaction that you've probably already had. When you first view the conference website, it loads all the session and other information on partners and stuff from Firestore, as well as images and other static assets from Google Cloud Storage. Then when you want to take an action, like bookmarking a panel discussion, you'll log in using either your Google account or email address, and the apps use Firebase Auth to authenticate you. Then when you register for a session such as this one, the app makes an API call out to the third-party system to update the logged-in user's set of reserved events, but it also immediately writes that session metadata back to Firestore. This eliminates having to poll on session availability so that as soon as an event actually fills up, its status will be displayed as full to all the apps. So thanks to the folks over at Nerdery for building the apps that we're all using this week. Now we want to show you the scalability and ease of use of Cloud Firestore. We have a demo that illustrates how a large number of concurrently connected devices can receive updates from and write updates to Firestore. This will be visualized shortly in a Google-colored Firestore logo display with pixels that represent the end-user devices in each of 4 colored quadrants. Then to reflect the quadrants' updated colors in real time, we use one of the major features of Firestore, which is the ability to listen for changes at any node in your data hierarchy. So you'll see pixels updating their color as new color values are written to the documents for each quadrant. If you want to see this visualization, please visit firepixels.app and also hold up your device to us when it's loaded. I will do this as well. So you should see something kind of like this. Would be awesome, seeing a few following along. Yeah, thanks. Can we also transition to the demo screen? Here what we're seeing is that we imitate devices, which are our clients, with Node.js processes. And every simulated device gets assigned a pixel in this entire grid, totaling 40,000 pixels, essentially 40,000 concurrently connected devices. Making a quadrant of pixels change color is done by writing a new value to the color field in a document for each quadrant. Then we set up the clients to listen on the input document for each quadrant, and when it gets written, they'll read the new color from the data snapshot and write it back to the pixel document in Firestore. As the pixels' color values are written, you'll then see their corresponding pixels in the display change color. Currently, you're seeing some of these color changes every handful of seconds as there are some automatic changes happening, as well as people probably playing with the demo in the storage showcase booth, which is on the ground floor of this building. So we can also actually edit this or make the pixels and quadrants change colors ourselves by writing the data. And in order to do that, let's actually bring up the Cloud Console. So here's a view of the Cloud Console we've navigated to the Firestore data viewer. And over here, you can see the 3 collections that we have for the many devices. These are numbered. We have as many simulated devices as there are total spots with an X and Y coordinate per quadrant. We have pixels that get assigned to each device, and each pixel is named for its X and Y coordinate, has a color which matches the color of the input document for the quadrant, as well as a partition that's used to parallelize and speed up the UI updates, and an updated timestamp. And we can look at the input collection. So here are the documents 0 through 3 for all 4 quadrants in the logo with a color that we can actually set. So right now, the green, this quadrant 0 is green, although this, something about doing demos. I'm gonna check my phone real quick to see if it's updated. Let's see what happens when we write this value directly in the data viewer where you can view real-time updates and modify your data. Sorry for the hiccup. So in this case, we actually, if you're looking at it on your phone, you should see that some of the quadrants have pixels that are mixed colors, or individual pixels that aren't all the same color in the quadrant. And usually these represent the devices seeing that a new value has been written for the color for that quadrant, and then the clients will asynchronously pick up that update, write their color back, and this then gets updated in the UI, which is how you see different pixels trickle into the new color that they should be. This will be going on, and you can actually play with this demo on a few real mobile devices at the storage showcase booth. One thing we should be able to see in the data viewer is that if you change the value of the input here, the pixels should reflect their respective quadrant. So because it has a listener on the input field. So here, say we set the input to blue, then we go over to the pixels, and it's now been updated, whereas it was red before, if you had noticed that. We change this to green, and then these values are updating in real time in the data viewer. And one other thing of interest, especially for people who are writing applications that use more complex queries and therefore need to configure indexes to support those queries, you can navigate over to the indexes section And here we have, in our case, one composite index defined on the pixels collection and 2 fields, which enables a query used to load the UI. And this is the new feature under single field indexes, where each project is automatically configured to have all of their fields indexed in ascending, descending, and array contains modes. But since you want to, as a general pattern, avoid indexing monotonically increasing or decreasing values, in this case, we have disabled indexing on the fields that represent timestamps, last updated timestamps, to make sure that our app keeps performing smoothly. Can we transition back to the slides? Thank you. As an overview of how this app is set up, we have the devices simulated as Node.js processes running in Kubernetes pods with separate pods for each quadrant. Each of those processes then sets up many pixels, each associated with a device, and as well as setting up listeners on the Firestore input document that has the color per quadrant. We can change the colors in the display either using a controller app that you can see, it'll be on a Pixel phone at the demo downstairs, or via just changing the data directly in the Cloud Console, which we just did. This writes to Firestore, which triggers more updates for each pixel document. Then, with thousands of pixels updating at once, we used a Golang backend app to send the new colors to the Firestore logo display using WebSockets, which for us is a workaround so that the browser doesn't try to process thousands of updates at once, but you can see that Firestore does scale to handle many reads and writes in real time. To show this a little more concretely, here's a code snippet using a key feature of Firestore, which is the real-time updates. We have the at the top references to the database and each of the collections in it, and in our init function, we actually call this setup listener for each spot. This is per process that after we've spawned many. We set up a listener on the input document per each of the 4 areas, such that when that gets written, we invoke our callback that grabs the data snapshot and writes the new color value to the pixel document, which then gets rendered in the UI. So there you have it. We are using Firestore to sync app state in real time, and it scales up to tens of thousands of concurrently connected devices, and you can have ultimately millions of clients using your app. Now, we'll hand it back to Dan to wrap up with some considerations to keep in mind as you build and grow your Firestore apps.
Thanks, Kathy. So I want to just run through a couple of quick points to keep in mind when you're building larger apps before we go into Q&A. And I will not try to do any demo on conference Wi-Fi. So the first thing to remember as we're learning, we've used a lot of customer applications that are now part of our test suite and stress tests in particular. So one thing to consider when writing your application is how do you write scale? And so a couple of guidelines that we have. The first is for each individual document, try to keep the sustained update rate to once per second. So we do multi-region replication across data centers that are geographically dispersed. So there is some time of speed of light considerations as part of that. You can, of course, burst higher, but if you do a sustained rate like 30 a second for a long period of time, eventually your app will start to get a lot slower. The other one, which Kathy mentioned with monotonically increasing and decreasing values, is keep the writes of those types of data to around 500 per second. When our system splits, we do horizontal key ranges, and we split on either side to have more servers take care of that load. When you're just appending data to the end of, say, indexes or primary keys or prepending data, then all the load ends up on one side of the split. So we'll only ever have one server taking care of that load for you. When you're using the native mode, we support, at the moment during beta, 10,000 writes per second. When you're in Datastore mode, we support up to 1 million writes per second. And this is around the real-time notification system and whether that's turned on or off. When you're ramping up your traffic, so if you've got large events that are happening, we have a rule that we call the 555 rule, which is starting off at 500 writes per second and growing at 50% every 5 minutes. And for read, think about 10x that. The other thing that you should consider is how your concurrent connections work. So as your user base scales, how are the number of concurrent connections that you have from your client libraries going to scale? So as a general rule, we support up to 1 million concurrent connections when you're doing 1 update per second per connection. So that's 1 million updates a second across all your devices. To put that in context, 1 million concurrent users is something like 10 to 14 million daily active users, depending on the makeup of your application. The other thing to just keep in mind is how much data you're pushing out to your clients, and generally it's about 10 megabytes per second across that list of clients.